Hi everyone. In today's challenge, we are going to solve this problem. The problem name is soup serving and the problem number is 808. Alright guys, so first of all, what we are going to do, we are going to clearly understand the problem statement. So first of all, we will understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript, I will share the link in the description. You can go through that particular link and you can find all the solution, right? So now, guys, let's see what this problem says. So let's understand the problem statement. So problem says there are two type of soup, type A and type B. All right. So we are given two type of soup, type A and type B, right? Fine. Initially, we have n ml of each type of soup. So we are given that is nothing but we can say input, right? So one input is given that is nothing but n, which is nothing but we can say integer, right? This will tell us that how many we can say ml of soup we have for type A and type B. Both will have same we can say ml of soup, right? There are four kind of operations. What is that? That is first operation is nothing but we can serve 100 ml of soup A and 0 ml of soup B, right? Second operation either we can say serve 75 of ml of soup A and 25 ml of soup B. Third operation is serve 50 ml of soup A and 50 ml of soup B. And fourth operation serve 25 ml of soup A and 75 ml of soup B. I hope it makes sense. So these are the four operations which we can perform, right? Either we can serve 100 ml of soup A and 0 ml of soup B, or 75 ml of soup A, 25 ml of soup B, and keep going, right? So this is nothing but we have four operations. Fine. After that, we can say when we serve some soup, we give it to someone and we no longer have it. So let's say I have some, let's say I have 500 ml of soup, let's say 500 ml of soup A and 500 ml of soup B, right? So let's say I perform a second operation. Serve 75 ml of soup A and 25 ml of soup B. So what now I will gonna have 425 ml of A and we can say 475 ml of B. So this means that we are gonna lose it if we are serving it. We will not have any more in our we can say this so A and type A and type B, right? So fine. Now what they told, each turn we will choose from the four operations with an equal probability. Now guys, this operation you're not going to perform by like on big some condition. You will perform, we can say on performly in on the basis of probability, right? Equally. So if they have done equal probability, so means nothing but you are performing on a equal probability, means you have you can either perform this one, this one, this one, this one. So you have to perform on the basis of probability, right? So that is nothing but if you're performing this one, so your probability is nothing but 1 by 4. If you're performing this one, so your probability is nothing but 1 by 4. If you're performing this one, so probability is nothing but 1 by 4. So right, you can perform any of these, but you will have equal probability performing each operation. So if you any of the operation you are performing, your probability is nothing but 1 by 4. That is nothing but 0.25, right? So the same they have mentioned. Each turn we will choose from the four operation with an equal probability of 0.245, 0.25, right? If remaining volume of soap is not enough to complete the operation, we will survive as much as possible. We stop once we no longer have some quantity of both of type of soup. So let's say you are left with only 30 ml of soup in a, not 30, let's say 20 ml of soup in a type A, right? So but you still can perform this fourth operation, right? Because it's fine, right? Third as well, two as well, one by, because it's not zero. They have told that if we are not have that much quantity of soup but still we serve it, but we will stop serving when we have a zero, right? We have less than zero or zero equal to soup, right? Otherwise we will keep serving this one. Fine. And note that we don't have any an operation where all 100 ml of soup B are used for. So this is the very important line, guys, you have to understood, because this is going to help a lot. We don't have any operation where all 100 ml of soup B are used first. So you can see we have one where all 100 ml of soup A is going to use, but not B, right? You can see on B we have till 75 at max. We don't have sub 0 ml of soup A and 100 ml of soup B, right? We don't have this operation. I hope it makes sense, right? Return the probability that soup A will be empty first plus half probability that A and B become empty at the same time. Answer within the 10 is 5, 10 is minus 5 of the actual answer will be accepted. So now guys, simple question. Now it's becoming a really easy. What we need to do actually, we need to just find the probability. And what is that? Probability of getting A soup empty. Right? Probability of getting A soup empty first. But B is not empty, but A is getting empty. Right? So first condition, let me write in easily. A is equal to 0 or less than 0 and B is not equal to 0, B is greater than 0. It makes sense, right? I hope it makes sense. Second, plus half the probability that A and B become empty at the same time. Second is both are 0. A is less than 0, so let me write here A is less than or equal to 0 and B is also less than equal to 0, right? So we have to find these two probability, right? We have to sum of these and we have to find return this probability. Nothing else we need to do. Simple thing. And how we can do this? Let's see that part. So let's see first of all this first example, then try to understand how we are getting this 0.62500, right? So we have n is equal to 50. So that means we have 50 quantity, right? 50 ml of soup, type A soup, and 50 ml of type B soup. Fine. Now what we can perform? We can perform any this four operation on the base of probability, right? Each we can say equal probability. So what we are going to do, let's say we perform the first operation. So that means we have to give 100 ml of soup A and 0 ml of soup B. So if we do that part, let's say I'm performing the first operation. If we do this part, so what we are going to get? We're going to get minus 50 of soup A, means it's become empty, and B does not become empty, right? B is still 50. So we can say this is going to be our what we want. We want A should be empty first. So we can say by performing the one operation, we are getting a probability 1. Okay, let's perform second operation. What we are going to do in second operation, we are going to give 75 of soup A and 25 of soup B. So if I give 75 of soup A, we have already 50, only 50, right? So if I give, I will get a negative. That means it's going to empty, right? And B is also getting empty or not? You can see B will not get empty because we are going to give 25 and it's have 50. So it will still remaining 25, right? So we can say it's going to be again a 1. Why? Because A is getting empty, right? We want this, right? A will should be empty first. Fine. Now let's see the third operation. Third operation is nothing but we can say where sub 50 of A and 50 of B, right? If we are going to sub 50 ml of A, 50 ml of B, so both will become empty, right? So if both are getting empty, so we can add 0.5 because it's nothing but we want half plus half the probability of A and become empty. Half, right? 0.5. 1 divided by 2 is nothing but 0.5. Let's see the fourth operation. Where B is getting a 25 means here we have to sub 25 ml of soup A and 75 ml of soup B. So we are going to sub 25 ml of soup A. So you can see A is not going to empty, right? But B is getting empty. But B is getting empty, right? But we don't need to count. We need to count 0. Why? Because it's not lying in our condition. We don't want to. You can see either soup A should get empty, then only we need to add 1. Otherwise, if both are empty, then we need to have half the probability, right? But if B is getting empty, so we need to add 0 only, right? Because this is not we want, right? So here our probability is coming 0. Fine. So these are the four operations, right? So now what we are going to do here, we are going to say fine if these are the operation. So what I'm going to say, I have to multiply it by 1 by 4. Why? Because for getting these operation we have 1 by 4 probability, right? So let me show you here. So what I mean by this, for this operation 1 by 4 into 1 plus 1 by 4 into 1 plus 1 by 4 into 0.5 plus 1 by 4 into 0. So if I take 1 by 4 in common, then I will get 1 plus 1 plus 0.5 plus 0, right? So this is nothing but same thing they have mentioned in our explanation part as well. 1 plus 1 plus 0.5 plus 0, right? So then after we will get answers 0.62500. I hope it makes sense, right? So now I believe you understood the problem statement, what we need to actually do, and what is the basically problem part, and how we can solve this. Let's move to the logic part, right? But believe me, I believe you guys, you have understood this particular part, right? So let's move to the logic part and let's see how we can implement this one. So this was the really, we can say interesting problem. It's not going to take much time, right? I will clearly say that this part, that implementation part, you will have really, you will gonna really enjoy it, right? So what I'm gonna do in the logic part, we are going to see how we can solve this problem with the code, right? We have already seen with the manually that we are going to check this, but how we can solve with the code, right? So for code, we are not going to do anything else. Just we are going to say, let's make a recursion, something type recursion, where I have initially A and B, and both are nothing but we can say 50-50. If I'm taking a first example, right? Just this much you have to think. Rest you can easily make it, right? So what we can do, we can use a for operation. So here what we can do, we can give 100, we can say 100 serve, we can serve here 100 ml of soup A and 0 ml of soup B, right? So we can say subtract 100 and B remains say here serve 75 ml of soup A, so subtract 75 and 25 from B. Third operation, says serve 50-50 from both, so A minus 50, B minus 50. Fourth operation says sub 25 from A and 75 from B, so A minus 25 and B minus 75. So these are the four operations which we can perform from this particular main node. Main node is nothing but given input, right? Now if this is not getting a null, so here again we can perform four operation. Here also we can perform four operation. Here also we can perform four operation. So try to think about the just a recursion part, right? So this recursion tree is really helpful. So when we are going to stop this, so see guys, now there are going to be one condition here. The first condition is going to be if your A is becoming a less than 0 and also B is also less than 0. So what this means? This means that both become empty. If this is the case, then what we are going to return? We are going to return half of the probability. That means nothing but 0.5, right? But if second condition, if this node condition match, right, then we are going to check if a is less than 0. If a is less than 0, that means a become empty and b is not less than 0, right? Because other, if b was less than 0, then first condition should be satisfied, right? So that means we have to return 1 here. That's what we want. We want a should empty first. But a is also not less than 0, and a and so we have seen a and b both are not less than 0, and a is also not less than 0. And let's see now if b is less than 0. If b is less than 0, then we are going to return 0 because we don't want it. We don't want what we don't want. We don't want that b should empty first, right? So we are going to return 0. Fine. So if none of the A and B, both of these are not less than 0, then what we are going to do? We are going to move to the next equation part, right? Means they have some value. We can try to use our for operation, right? So these are the phase four, we can say base condition. So here you can see if we are going to perform here. So here A was 50. So what will A will going to here? Let me just now remove A minus 100. So it's going to be minus 50, and B is going to be 50 only, right? So here I'm going to say A minus 50. I have to subtract 75, right? So it's going to be minus 25. It's going to be plus 25. And here it's going to be 0 0, and here it's going to be we can say 25, and here it's going to be minus 25, right? Fine. So now you can see here a is less than 0, so we are going to return 1. Here a is also less than 0, we are going to return 1. Here both are less than 0, so if first condition is satisfied, so we are going to return 0.5. Here a not first condition satisfied where both are 0, not second condition satisfied where a is 0, a is less than 0, but third condition satisfied where a b is less than 0, so we are going to return 0. So if we do sum up, if we do sum up of all these and divide by 1 by 4, then we will get answer 0.62.4 0.62500, right? So I hope you are getting this part, right? Just simple, we need to recursion, and after that, once we getting from all side, we have to multiply by 1 by 4, nothing else. Sum of all these plus into multiply by 1 by 4. So let's move to the implementation part and let's try to implement this particular logic, right? So let's move to the implementation part. So here guys, I'm first of all with the Python, right? So you will see, fine, it's really easy, right? So first of all, what I'm going to say, I'm going to say let's say small function, and here I'm going to say a comma b. If a is less than 0, and let me write 0 and not 90, and b is also less than 0. So what we are going to return? We are going to return 0.5, right? But if a is less than 0, then we are going to return 1.0. If b is less than 0, so we are going to return 0 only, right? Fine, it makes sense, right? So after that, if note a and note a and b both are not less than 0, then what we are going to do? We are going to say move to the next four operations. So we can say return 1 by 4 multiply, you have to multiply, and then let's call all the four operations. First time we are going to subtract 100 from a and b remains a plus sold. Then we are going to subtract 75 from a and 25 from b plus sold. Then we are going to subtract 50 from a and 50 from b. Then we are going to subtract 25 from a and 75 from b, right? Fine. So this is done, right? So what we are going to do? So here guys, I'm going to call this function sold, and here I'm going to send n command, and here we can simply return, right? So this is the basically we can say problem, right? Not problem, we can say solution, but it will not pass all the test case because it's definitely going to give a TLE, right? So let's see. You can say it's passed the sample test case, but right. But if we try to submit this code, so definitely I'm going to get a TLE, right? Let's see that part. So it's taking a time, but definitely it's going to give a TLE, right? Let's see. So it's taking a time. Okay. You can see I got a TLE at the 10th test case, right? So let's use this test case. Why I'm getting a TLE? Because recursion tree is getting a long, right? You can memorize it, right? But here I'm using just a cache decorator. So let's try to run this code as well. So here, very interesting thing I'm going to tell you. See guys, it's passed all the test case, right? All the three test case and that last test case as well, which was getting TLE. But if you notice here on the n100, I'm getting a 0.96 probability, right? And if I just make a little more test case, so if I make one more test case, it is a really important thing you need to understand. So if I let's say I'm giving a 1000, right? And one more test case where I'm giving a let's say 5000, right? And one more test case where I'm giving a 6000. So try to understand thing what it's gonna happen, right? So let's say to run this code, it's gonna tell us what we are gonna happen. So they have given a one node as well, right? So I told you that focus over this part as well. So this node, right? We do not have operation where all 100 ml of soap are used first, right? So now let's focus our given test case. So case 4, right? Case 4 we are getting a probability 0.97. Case 5 where it's a directly we are getting a probability 1. Case 6 we are getting a probability 1. So what does this mean, guys? As soon as our number of we can say quantity n is getting increased, our probability is becoming n, right? And you can focus here, guys. After 5000, your probability is nothing but 1 only, right? When you increase to 6000, your probability will become 1. So we can make one condition here. If our n is not here, instead of calling this function, we can say here at the top only, if n is greater than 5000, you can directly return 1, right? It makes sense, right? So if n is greater than 5000, it's the probability will always be 1, because we are, why it is 1? The reason is this node. We don't have any operation where we are using all quantity to show b and zero quantity to show b, right? So we are not have anywhere we are serving 100 ml of soup b and 0 ml of soup a, right? So that's why it's always be approach, whenever the n is getting increased, it always be the, we can say the bigger probability that a will be empty first and b will empty later, right? So let's try to submit this code, and definitely we're gonna pass all the test case and we will definitely gonna submit it. And you can see, guys, our first test case, like this with Python, it's successfully got submitted. And now let's move to the next programming language, in the C++. And let's quickly, what we are going to do here, we are going to first of all say if n is greater than 5000, then we are going to say return 1.0, right? Fine. And after that, what we are going to do, we are going to say fine, let's call this function. Before calling that function, we are going to say fine, here let's make a map, and here it's going to have pair of int comma int, and here after that we can say our double, and this is going to have our dp, right? So instead of memorizing, I'm using a map here, and then after then I can make a function solve, and here I can say int a int b, and here I can say if a is also less than 0 and b is also not multiply and b is also less than 0, right? So what we can do, we can say here simply return 1.0, right? Not 1.0, it's half of it, right? So 0.5. And if a is only less than 0, then what we are going to do, we are going to return 1.0 because we want this. And if b is less than 0, so we can say directly return what, 0.0, right? So then what we are going to do, we are going to say double result. So result is going to be nothing but we can say solve. First of all, we have to multiply by 1.4. 1 divided by 4 is nothing but 0.25. So we can do like this. And here we can say solve a minus 100 plus, not plus, b, simple, and plus solve a minus 75, and we can say b minus 25, fine. And here we can say plus solve a minus 50 and b also minus 50, plus solve a minus 25 and b minus 75, right? Fine. And after that, what we can say, simply return this result, and we haven't memorized it yet, right? So let's see whether first of all it's passing all the test case or not. So for memorizing, how we can, what we can do, we can simply here we can check one condition. So it's saying that invalid data type, all right? So we have to call this function. Let's call this function. Let us solve and command, and let's see. It should pass some test case, but not we can say all of these, right? So what we can do for memorizing, we can say simply here, if our dp don't find, it's not able to find what, a comma b, right? So what we are going to say, if it is not equal to dp dot add, so what we can say simply, if dp is not equal to dp dot find is not equal to dp dot end, that means there is a key present in our dp, right? So we can say simply return dp of a comma b, right? But if it is not able to find it, so we are going to find it, and after that we are going to store in our dp, right? So we can say dp of this a comma b should be equal to our result, right? Now let's run this code, and I hope now, guys, it should pass all the test case, right? So you can see all the test case passed. So let's try to submit this code, and I hope, guys, it's gonna submit as well. So you can see it successfully got submitted. Now let's move to the next programming language, which is what we can say Java. And in Java also we are going to do a literally easy. First of all, what we are going to do, we are going to say if n is greater than 5000, so simply return 1.0, right? Fine. And after that, what we are going to do, we are going to say if it is not greater than 5000, so check calculate it. But before that, we have to memorize it. So here in C++ we have used map. Here we are going to use a array. So for how we can use array? So for array we are going to make a 2D array double. Let's say the name is dp is going to be new double, and its spelling is mistake here. That's why color has not changed to purple, right? Double, and here we can pass size is n plus 1, right? N plus 1, n plus 1. And by default, I want to put value minus 1.0, right? So what I can say arrays dot fill. I can't use a fills because it's a duty array. So then I can use a stream. I can pass our dp dot each. For each, I can pass a row, and here we can pass what we can pass. We can pass arrays dot fill in this row minus 1.0. Fine, now I can call this function solve and command, and I can say return whatever this value it's gonna return us, and I have to pass dp array as well. Fine, now let's define this solve function. So we can say public, we can solve, and here it's going to give a double return type int a int b, and we can say double, we can pass our dp, right? Okay, and here we can say simply if our this dp of a and b is not equal to 0, not 0 is not equal to minus 1.0, then we have to return what? We have to return dp of a and b, right? But before that we have to check our base condition, right? So what is base condition? So base condition is nothing but this one, right? If our a is less than equal to 0 and b also less than equal to 0, so what it's gonna do, it's gonna say return 0.5, because we want half of the probability. But if a is less than 0 only, b is not less than 0, then we want this, so it will return 1.0. But if b is less than 0, but we don't want this, right? So we have to return 0.0, right? Now we have done all these cases. Now let's see if any of these case not pass. That means nothing but we have to use all the four operation with equal probability, right? So we can say double, result is going to be 0.25 multiply, and here we can say solve. First of all, we are going to call a minus 100 b same plus solve a minus 75 and b remain b minus 25 and plus solve. Here we going to say what we can say, we can say a minus 50 and b minus 50, and the last nothing but solve a minus, and here we can say 25 and b minus 75, right? Fine, once this is done, we are going to put in our result dp as well. Dp of a comma b is going to be nothing but this result, and after that we can return this result as well. But see guys, we got one error here. We are not passing a dp array here, so we have to pass dp as well, right? This is a third argument in Java because we are using memorization with an array, right? So let's see. Fine, now let's see whether we can find or no. So it should pass, right? Let's see. We got an error. Why? If dp of a, oh right. So fine, now let's see. The last array is nothing but, okay, we have to remove from this. Fine, it should pass now, right? So let's see. You can see guys, all the rest is passed. So let's try to submit this code, right? And I hope guys it will also gonna submit it. So let's see. And it got successfully submitted. So you can see it's got accepted. Now let's move to the last programming language, nothing but JavaScript. And in the JavaScript, basically what we are going to do, we are going to use a nested function. Fine. So we can say guys, if n is greater than 5000, so we can simply return 1.0, right? But if it is not the case, so now let's move to the first of all make an array, right? Or instead of that, let's make a map. Once map is nothing but we can say new map, right? So this makes sense. Once this is done, then what we are going to do, we are going to simply say let's make a function solve, which is going to take a and b parameter, right? And then we are going to say if a is less than equal to 0, same base condition, a less than equal to 0, right? Why I'm doing this, I don't know. A less than equal to 0, b less than equal to 0. So what we are going to return, we are going to return simply 0.5 if a is only less than equal to 0, and we can simply return 1.0. And if b is less than 0, which we don't want, so we have to return simply 0.0, right? After that we are going to say if our map, right? So if map has key, then we are going to say return map dot get that key, and key is nothing but we can say what, so we can select key is nothing but, so we can say what, we can say we can use a dollar symbol here, and we can pass a, and we can make a dollar symbol here, we can pass b. So this is nothing but we can say we are making a unique key for every time, right? If a and b are getting repeat, so key will be remain same, right? And if key is also not in our maps, so we need to find for with all the equal, we can say of all these operation by running a equal probability, right? So we can say our result, so we can say that result is going to be nothing but, first of all you have to multiply 0.5 into solve and a minus, we can say 100, and b remains same plus, or n we can say b remains same plus solve, and a minus here we can say 75 and b minus 25, right? So then we can say plus a minus 50 and b minus 50. So what we can say again plus, and here we can say a minus 25 and b minus 75, right? And here we can say that's all. Just now you have to put this map dot set this, on this key you have to put this result, and then you have to return this result, right? Now let's call this function solve and command, right? And let's return this whatever this function is going to return to us. Now let's see whether it's working fine or not. And I hope so, guys, it should work right. I don't want to see any error. You can see all the rest is passed, so let's try to submit this code as well. And I believe, guys, it will ask for a submitted, right? Because we are using the same logic here as well. So you can see it's successfully got accepted. It's beat 100% of the user with JavaScript. Fine. So guys, we have seen the implementation with Python, C++, Java, and JavaScript. I hope you understood the implementation part. If you have any kind of doubt in the problem, understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.